Okay, so the next stage in the process of the window frame manufacture is to put the rebate mouldings and all the drip mouldings and sills onto the pieces of timber. So you get the picture by now. Before we start, we're going to make sure the beds and the fences are nice and clean and well lubricated to let the timber pass through easily. We quite often find with a spindle moulder on the fences, especially the in-feed fence, when you're setting it up, you'll constantly find as you run the material through that it points away from the outfeed fence and you get a tiny gap between the timber and the outfeed fence when the in-feed fence is tight along there. The reason you get that through working with the machine is the material's being thrown this way into this fence and will gather a tiny bit of dust and etc. on the back of the fence, and when you go to change cutter you release it and slide it back and it just transfers some of that dust onto them surfaces where the fence actually clamps to, and when you slide it back into place and lock it on again, it's creating a wedge effect on that fence. So that will be the reason why the fences don't always align up after you've changed cutter or something like that. So just bear in mind when you're setting up, just keep these the backs of these fences nice and clean, and again the plate that the fence engages on, you can see there's a fair bit of dust already on this. Just clean all that residue off. Make sure it's nice and flat surface, and you shouldn't have a problem with the fences aligning. So the first cut I'm going to do is the rebate. The guy I'm doing the video for has got a 50mm rebater. We need a 63mm or 64, 65mm deep rebate in the frames. So we're going to have to alter the cutter and do it in stages to build up that rebate. So initially I'm just going to work the rebate depth to near full depth. So instead of going 15mm deep, I'm going to get to about 14mm with a cut full height. So we've made a full height cut at 14mm deep, and then I'm going to just trim that last little bit off as a last cut. So to do that, I'm going to take about a halfway cut, so around 30mm, 35mm high into the timber, and we're going to cut that in about I don't know, 6mm deep. Depends how strong your machine is and how steady it is. So if it's just quite a lightweight machine, you don't want to be taking too much material off in one pass. The rebate cut is going on that edge mark, so the V mark, and on the outside face, so the opposite side to your face mark. So we're machining it with the cut downhill, so the face side will be up, facing up on the machine. I'll just run that through so you can see what the first cut's going to look like. So I'll run all the pieces through that are having a rebate with that cut, and I'm going to wind it up to the full height at the 64mm, so it just touches that mortise position. So I'll try and get the camera in above the spindle. If you've got a power feeder and you're setting it up, you want to, so the front of the machine, or the front of the power feed here, has a bit of a gap against the fence, and then it's fairly tight at the back of the machine, so there's a slight taper as it pulls the material into or through the machine. It's actually pushing it very slightly against the fence at the same time. As you can see here, the power feed is nice and tight to the fence here at the back of the machine, and there's a gap towards the front of the power feeder between feeder and fence. It just gives it that degree of angle so that the timber is forced against the fences. In terms of the height setting of the power feeder, This wants to be about 5mm lower than the thickness of the timber to the underside of the wheels. Just gives enough spring pressure on the wheels for it to be able to drive the timber through. If you find your timber is stopping as it runs through the machines and you've lubricated the beds, it could be because you've got too much pressure applied on your power feeder. In terms of speed for the power feed, you'll sort of get a feeling for the speed. You'll know when it's too fast, and there's not really too much of a downside to going too slow, but it can affect the cut quality if it's really slow, or the spindle speed is too high. So you can play around with it and see what sort of cut's right, but it's best to start slow and then work your way up to what you feel comfortable using. Okay, so that first cut was just really a clearance cut. When I'm rebating, I don't like to do too deep of a cut in one hit for a start, especially if you're using a coir. It just creates a really nice edge along that corner where your draft seal sits if you do a smaller cut for a start. So anywhere from sort of 3 to 6mm is perfect. And we're just going to raise that up now and do that first sort of shallow cut at the full height, so 64mm or wherever your mortise position is on the timber. Okay, so there we go, that's 64mm deep rebate. It's nicely taken that tenon away, so you can see now why we need the setback, because that tenon is being reduced as the rebate gets deeper. And the rebate there against the mortise has just cleaned it up nicely, so that's perfect height, bang on 64mm, which is what we wanted. I've run all them through to get that really nice sharp edge with that shallow cut. And because we've made that cut or rebate in the timber and there's now a gap against the fence when it's being machined, you'll get quite a bit of dust and chips coming out the front of the machine. Just clear them off with every piece so that you've got a nice accurate reference face on the base of the machine to stop it being thrown by the material and doing an inaccurate cut. Okay, so now it's just the same principle with the rebater all the way back until we've got a 15mm deep rebate across that entire depth. I'm going to machine the 15mm by 50 from the top of the cut so that the 50mm depth cutter and that bottom spur cutter is that about 14mm from the face there. So what I mean by that is, because we're using a 50mm cutter and it's not cutting it in one pass, the bottom of the cutter block, which I'll show you in a second, has a spur cutter, and I don't know if you can see it on the camera, but it leaves a groove in the timber like that, where the spur cutter sticks out just beyond the blades. So what we're going to do is have that 50mm cutter at the top, and when we do the remainder of the cut on that final pass, it will just be from there down, and we'll get rid of that groove within the capillary groove like that. So the capillary groove will actually chop away that imperfection left by the cutter. So what we don't want to do is set the cutter up to the 30mm high and go in and do our 15mm deep cut there, and then finish off the cut with that top section, because we'll be left with that nasty groove in the finished rebate. So there's a few options for doing it. You could just groove straight down to 15mm for a start, so do your 3, 4, 5 whatever deep groove for a start using the rebater, and just keep dropping that depth into 15mm, or do as I've done here, and we'll now work that back to the 15mm and then drop it down and take that last piece out. I like to do a full rebate for a start at that shallow depth as well, because if you've got any discrepancy on the squareness of your timber as it sits against the fence, because you've removed all that material there, if it's slightly out of square in this plane, because you've removed the material, you're only getting the inaccuracy of the out of square over this small portion of the timber, so you get a slightly more accurate joint even if your timber's out of square. So I would personally rebate full depth like this in a shallow rebate, and then we'll work that top groove back to 50mm and then take off this last bit as a final pass. Okay, so I've just dropped the cutter in the moulder, so it's 14mm high cut, 15mm high cut, so it just clears that last little bit. This is only at 14mm deep rebate. I'll do a final pass, taking it down to that final 15mm depth, so we get a lovely clean finish. The cutter's not doing too much work, it's just doing a nice cut. Okay, so now I'll just move it back and set it up on the vernier caliper to 15mm rebate. Okay, so then we're just going to wind that cutter down. So where the bottom of that rebate cutter sat, I just ran that about 2mm higher than that position, so that it was the cutter that was doing the cutting and not the spare bit. But it doesn't matter too much, you can run it perfectly in line if you wish. And that should leave you with a pretty much a perfectly flush line all the way along that timber, as long as you've kept the power feeder keeping a nice pressure on the bed and nicely against the fence. Everything should be running in line and true. And that's the rebate done. Okay, so we've now formed our casement rebate in all the pieces. We can check this as we're machining it in the sills, as long as we've machined this tenon down to thickness, or we can rip this in half on the bandsaw or something to make it narrow, so it can be used as a checking tool in the sills. So if we just pop one of the sills on its flat and put the pattern piece into it, we should be able to check the joint fit. Just going to have to clean the mortise out from the mortiser. The chisel leaves some like residue in the corners where the drill bit doesn't quite clear the square corners of the chisel. You can do a deeper mortise to get rid of that, but I like to have it fairly tight so you've not got big gaps in your joinery. Be really careful not to damage these edges on the timber after you've machined them, because they're really important to keep nice and clean. So we can use that test piece just to sit into the joint and check how it fits together. We can also use the actual tenon that's going in there at this point, and just have a quick check throughout the process that the joints are going to line up nicely. Don't be too worried if you've got a minor discrepancy between the two shoulders, you know, sort of a ½ gap in difference. It's not the end of the world, especially with the rounding corners on all the joinery that you're going to fill with a sealant. So it's not the end of the world if there is a gap there, but we want to get that really as tight as we can on them joints. So next we're going to look at machining this draft strip groove here. We're going to need a saw blade or a cutter to reach that point there to cut the depth of the draft strip groove. It's about a 5 to 6mm deep cut, and obviously we've got a 64mm rebate, so we need a fairly decent radius cutter to physically reach that point with the bearings and the spacers on the spindle not getting in the way. I've got a saw blade here. It's just a cheap Bosch one that I use for putting the 2.7mm groove in. So it's a 2.7mm curved saw blade. I forget what diameter is. I think it's 180 or something like that. 190mm diameter. And I've actually had a spacer made to suit this blade here that looks like this. So it's a bit like a top hat spacer. But when you use this with the blade, it gives you a bit more depth of cut to the actual spindle without the spindle fouling the cut there. So you can get about a 75mm depth of cut, whereas with some of the washers on my spindle, it's not quite deep enough with this blade. So you can use a blade like this, but you might need a spacer to physically make the timber reach the depth of cut. You could also use a router with a bearing guided bit just to make that 2.7mm slot there for the draft strip groove. Alright, so we pop the saw blade in. I have to sit mine quite low on the spindle because this is quite a tall spacer. But you can see I've got a decent 72mm cut there to that spacer edge, but with the extra depth there I'll easily get 75mm of cut, whereas a traditional spacer like that, yeah, it's around 70mm, so Should be fine with a normal spacer using that saw blade for this specific window, but sometimes I've required the extra depth that this will give me. So when we're tightening a cutter in the spindle moulder, they always rotate towards you from left to right, so you always feed the material in from right to left, unless you've got a reversing spindle moulder, in which case you can reverse the cutting direction of the tool and actually cut from left to right. So because it cuts in that direction, we tighten up like a normal bolt, so it's a righty-tighty bolt, if you want, and a lefty-loosey, and we don't want too much pressure on there. There's not really an awful lot of force working on the cutter if they're all nice and sharp, so literally to tighten that cutter down, you don't need to be forcing it and getting a real strong sort of tightening force on there. It's just a nip, so it's just enough to tighten it up, and that's it. So don't go wrenching that nut or that bolt too much to get plenty of tightness on there. It's not required. So with this cutter, how I machine it is I just sit it off the bed, the height that you want the draft strip to sit at. So we'll set that up roughly using the actual strip itself from the bed, and then we'll get a test piece and run it into that. So what we're looking for is when you cast your eye along the edge of that surface, it looks best when you can see about half a mil of draft strip sticking up from that edge there when you cast your eye along it. So that's about perfect. In terms of measurement, that is let's have a look, 0. It's about 6.7 mil from the face to the groove, and then you've got a 2.7 mil groove. So now we've set the height, we will wind them fences right back, and we want to be cutting into this groove here. So when it touches the rebate, you'll see the saw stops the wood from moving. We've got to go in the depth of cut to allow for this strip on the draft strip here to enter the timber, which is about 5 mil. So we'll hold that there, roughly eye the 5 mil by winding the fences back. Then we'll do a test cut and see how it sits in the wood. Got to be really careful with this. You can use the power feeder for this if everything is running through, but quite often you'll find you've got stopped grooves. But for this job, you can use the power feeder. You could set a 15mm piece of timber either side to support the workpiece from tipping in. It's probably advisable if you're sort of not used to what you're doing, but you just want to make sure that that stays perfectly square against the fence and the bed, and that it doesn't dive in like this, because it's just going to wreck that piece of wood. So you can add some bits either side to stop it from doing that, but you should be fine if you're careful. Obviously, if you've got really small bits, sort of like this, that you're going to be machining right through, you might want to use a false fence on there, or add an extra piece of a fence on that will get closer to the actual spindle itself. The reason I've got this special cutter on here, or collet, it's just a billet piece of steel that's been bored out to the same size as the spindle and then machined away to make it thinner. It's to allow me to get a deeper depth of cut with this saw blade, so that the spacers from the spindle moulder don't get in the way of that edge of the timber. It allows me to do this cut on up to a 70mm rebate. So we're going to run this draft strip groove in everywhere there is a rebate. you're going to use the power feeder, you've got to make sure that the wheels don't apply any pressure over the rebate section, so it's only on the part of the wood that's engaged in the bed of the machine. You sit it up this way around, put a slight pull on the wheel, so it's slightly pulling it into the fence. Check front and back aren't going to be pushing on that rebate when it's this way up. I've pushed one through by hand carefully, just to put the groove in place so it's not going to affect it. I can test the wheels now, because that groove's there, the cutter's not going to get in the way. So using that one with the groove in, I'm just going to test that it's not going to deflect that timber as it goes through. Set the height first. Perfect, so we can use the power feed to pull them through and do a nice accurate spindle groove. So all the pieces should have this draft strip groove in place now. We'll move on to cut the capillary groove into these square sections of the wood. The only bit we're not putting a capillary groove in will be the one that's marked Sill. So Sill I'm going to put to one side and not put this capillary groove in it. Okay, so the capillary groove, this is an 8mm diameter drip head from Whitehill. So it's just a circular carbide cutter on a 8mm diameter body, and it just creates a groove with an 8mm diameter end to it. We want to sit that groove within that 14mm zone that the 50mm rebate cutter left that groove in. So we've got that slight score line there from that rebate cutter, and this capillary groove will chop that out. So we want to set that up so it's roughly in the middle of that. But we also want to check with the hinge where the centre of them screw holes are, so that it's not affecting that as well. Just happens to fall quite nicely. That's where the hinge hole will be, plus 2mm, so roughly the back of that hole, and that's the 14mm line. So if we set it up as that being the centre, somewhere there it's going to be about perfect. We want this about 3mm deep, the capillary groove. So that's the groove, and the hinge will sit roughly in that position there, and by the time the hinge is recessed in, you shouldn't see any groove, or just a tiny bit of the groove in the hinge recess. Right, so next we're going to turn our focus to the sill. I know that Mark, who's making these windows, has got a 9-degree sill block in his collection for his Spindle Moulder, so we can use a nice big cutter to do the sill all in one pass, which is quite handy. I'm going to use my rebater, so I don't use a 9-degree block, but it's exactly the same principle. So I'm just going to tilt this back to 9 degrees. I'm going to set the height of the cutting spur on the block. So these ones at the height of that rebate, or just under it, you want to be about 1/2 mm underneath that. You've got to get that point right at the front point of the block and drop it down. So we're about so it's just going to clear that block. It's the same with the sill block. That spur will be square, but we just want to be just below it so it's not going to interfere with that cut we've already made. and then we're going to set that block to cut the sill. In terms of depth, you want to start at about 7mm depth and then work your way back using your joint as a guide to get the setting correct. So about 5mm there. Let's use that as a starting point. So we've got our mortise in our test piece. We'll run that sill cutter through. In terms of setting your fence in regards to the cutter, this back fence can be quite close, so as close as you dare really to the cutter, within reason, so 2 or 3mm is fine. This front fence, depending on what you're cutting, you want a bit of gap there, so generally you want at least 5mm, but if you're doing a deep cut, you're going to have more of a gap there, and that's just to allow the chips to exit the wood. And if you've got a particular species of wood that likes to sort of spur away before it's being cut, that will help keep the cuts consistent, having a bit of a gap there. If it's dead tight and the wood likes to just pull a bit as it's being cut, it's going to ride on that cut and produce an inaccurate result. So you just want a tiny bit of clearance there for that to allow the cutter to work. So if you've just got a test piece with mortise in it, that's perfect. And we can take our actual bottom cut of the sill and use it as a guide to set that depth. You've got to be dead careful when we're setting this, because they can be a bit wobbly as you're setting it, so you want to get a ruler on the face of the wood and make sure that that piece is dead in line with this piece as you setting that cutter to make the joint the same on both sides. So looks like Sill wants to cut slightly in, so we want about another 2mm on that one. So as long as you've got that perfect 9-degree cut, you just wind that cutter back until this shoulder here meets nicely at the same time as this shoulder here. I wouldn't worry too much if you've got a tiny discrepancy in the fit on the frame there. You should be pretty accurate doing it this method with mortise a second, but you could always, if you really wanted to, just plane them in a little bit by hand. But as you do more of the joints and as time goes on, you'll get a bit better at setting them up and getting better results. But that's the sort of fit you're looking for on the joint. So we'll run all the sills through at that setting on the bevel mount. Okay, so the next cuts I'm going to use is a 10mm groover, and that's to put the sub-sill into the actual sill, so to join the two together. So I'm just going to lift that up on some spacers because that's as high as my machine will actually travel. Again, you want the cutter as low in the cutter block as you can get away with, really. But small cutters aren't too essential. It's when you get a big, heavy sort of profile cutter, if there's any imbalance in the cutter, you're going to really affect them bearings. And just a nice nip up to tighten the cutter. So see on the drawing here, we've put the sill in at 27mm from the base of the sill section. So if we measure 27mm to the top of the cutter, and that wants to be about 8mm deep. Now while that cutter's in the machine, if you've got a full sill and you're not adding a piece on like I am to make up the height, you can add a window board groove in at 25mm, so 25mm high by 10mm deep, and that will be the part of the sill where the window board will slot into to locate it and keep it nice and level. I'm not going to do that on these. Mark's got the choice who's making them, whether he wants to put one in. If he's going to do it and he wants it 25mm from the bottom of the window, he's going to have to do it 15mm to the top of that and just have 5mm of timber left on for that groove to locate into because of that extra 12mm that we've got sat underneath the window. So the very last thing that we're going to do on the spindle moulder here for machining on the frame is just put this radius on this sill section at the front. Every other radius on the joinery, I'll do the little hand router, palm router, because it's all 3mm all the same. It's nice to have them exactly the same along the long grain as on the end grain. But obviously where you've got a bevel, you can't use a router unless you've got a beveled router bit, so we'll just put that little radius there on with the spindle, so we've got a nice smooth curve for the top coat or the paint system to attach to. We've not got a sharp edge at that point, because that is one of the most critical points on the window for where the water ingress is going to get in. So I've got a cutter here. It's quite an old one. It's about a 12mm Quadrant Cutter. And I'm just going to set that on the tilt at 4.5 degrees so that it's even between the 9 degrees of the sill, and make the radius using this, just using part of the cutter. So after all the machining's done on the spindle moulder, we can check each section against the cross-section drawing and make sure that we've not missed anything. The radiuses on the profile, like I said, are going to be put on by a router with a 3mm bit. Everywhere it's square, the router will do that nice and consistently. So that was the sill. This is the head section, or the same as the head section. And the jamb, and then we've got the mullion there as well, so everything's been machined as per the drawing. So the only thing left to do in terms of machining the frames, other than that trickle vent groove, is to put the 3mm radius on. I'm using a Axminster 3.2mm radius cutter, and it's just in a bottle router like this. And I put a sacrificial fence on, so it's nice and close to the, not fence, base plate. It's not a zero clearance, so you can actually still see in through the machine to where you're cutting to, but it's a lot closer than the standard base plate, and gives you a bit more accurate results on smaller pieces. So we're going to be putting this groove essentially on the joint surfaces for a start of the window. So it's just along on the sill here, it's just along this face here, and we on the outside as well. So we don't need to do the outside on the joint because it's already been done on the spindle moulder. So we've got that 3mm radius on the inside of the sill. On the head of the window, we're going to do the outside edge where the joint meets, and again the inside radius. The reason we're not doing all the way around the piece of timber is we can do that once it's been assembled and screwed and glued together. If you wanted to, you can cut the ends of these sills along the lines that we set out for the width of the window, nice and square, and you can also put the 3mm radius using the router on the end grain like this, and create a V-groove in the side of the window as well that you can seal at the same time. But if it's sealed in against the brickwork, it's not particularly necessary, and if you have to do any planing of the window, then you lose that anyway. So generally I'll just leave that square and just have the V-groove in the front of the joint. And on the jambs of the window, we're going to do the end grain, so that's the point at which the joint meets. So that's essential to do now. We can't do that after it's been assembled, and we're going to need to come up this long grain at least enough for the router to get in, so just to do a short bit, but generally I'll run that all the way up that inside edge now, instead of just leaving it for later. So all we've got to do later is the extremes of the window with the router. With regards to the bevel on the sill, depending on how your bearing's set up on your cutter, I would just run it along that bearing and let it cut that tiny bit deeper because it is beveled. It's nicer to have a bit bigger gap in that sill joint where it's going to get the weather, so you've got more chance for the sealant to survive in a bigger gap. So I let the cutter cut a bit deeper. If you're worried about that and you just want a small radius on that point, you'll have to sand that in by hand or with a sharp plane or something like that. So I just use the router. Good example there of not paying attention. I've gone a little bit slow on that end grain and it's actually burnt it. So you've got to maintain a decent cutter speed with oak, else you're going to get burn marks, but we'll have to sand them out gently before we assemble this frame. Doesn't help that my cutter's probably not particularly sharp. It's done a lot of work. Same on the inside, we're doing the two end grains and running up that inside corner. And on the mullion, we'll do everything on both sides. You can use some of the machine wax on the base of your router and it'll make it slide so much easier. So at this point we should be able to assemble the frame. You might just have to clean the spurs of wood out the bottom of that mortise using a 5/8 chisel or less, and just work them edges out that the mortise leaves, so that the mortise or the tenon has got enough depth to go into. And then we should be able to just dry fit the window together. You can stand back at this point and admire your hard work. So these joints will pull up nice and tight once the clamps are on it and it's screwed together. We've got a little bit of work to do before we do the glue up on this frame, but we're getting to a point now where we can see what it's going to look like. From the face, this is what the two radiuses form, so it's a V groove in the joint here, and we'll fill that with a V groove sealant.